How do we solve for the area of shaded region? Before we go to the details on how we could solve for the area of shaded region, let's first go to the basic formula that are actually needed, like the area of the square, which is obtained when you are multiplying the side by itself. So here is the formula. For the rectangle, we have the length multiplied by the width. For the triangle, we have to multiply the base and the height, and that after we have to divide by 2. For the parallelogram, we have to multiply the base and the height, while in the trapezoid, we have to add the two bases. So we have the base 1 and base 2 all over 2. That means you have to divide by 2 and then times height. So remember that in the trapezoid, the bases are the pairs of parallel sides. And you have also the area of the circle, wherein you have to multiply the pi, which is approximately 3.14, and then times r squared, which means radius times the radius. So these are very important because these are actually the ones that will be of help if you are dealing with the area of shaded region. So basically, the problem arises because of the possible formation of your irregular shapes. Okay, so in this case, we have a circle, and there is an unshaded portion, which is a triangle inside this circle. So the thing here is we are only to find for the area of the shaded region, which is in this example in blue color. So what are we going to do here? So the first thing that we have to take note if you are dealing with this is to figure out what's the area of the whole thing. So we have to look for the area of the whole thing as if the triangle is not existing. Okay, so we are assuming that everything is shaded. So therefore, the figure that is involved there is the area of the circle. And since we know that the area of a circle is by simply having the pi r squared again, pi, that is 3.14, and then r raised to the second power. So you will notice here also in our example that the 9 here pertains to the radius of your circle, and at the same time, this is the base and the height or the altitude of the triangle. So therefore, computing now the area of the circle, we simply have the pi. We will be changing that pi to 3.14. And then the radius is 9 cm. So we have to substitute that. Multiply 9 cm by 9 cm. Okay, so you have to differentiate this from your circumference because the circumference is 9 times 2. Okay, that's basically a different case because when you say circumference, it will be just the distance around this circle. Okay, and then all we have to do now here is to multiply. So 3.14, and we need to multiply that by 81, which is the product of 9 and 9. So times 81. And do not forget as well that the unit of measure that we have now is raised to the second power. So cm times cm is cm raised to the second power. Okay, or cm squared. That is basically because we are counting the number of square centimeters in the circle. Okay, so the next thing is we are going to multiply that. So 3.14 multiplied by 81. So we do the distribution. There we have 4, 1, and then 3. So we just have to copy since we are multiplying by 1. And then for the 8 and 4, we have a 32. So we have there a 3. 8 plus 3 is 11. We have 1 there. So 24 plus 1 is 25. Okay. So adding this, we have now 4, 3, 4, and 25. We just bring that down. 25 point or two, there are two decimal places, so do not forget the answer that you have now for the circle is 254.34. Okay, so that is now the area of the circle, 254.34. And of course, the unit of measure, which is centimeter square or square centimeters. Okay, the next thing that we have to do now is to find for the area of this triangle because it's the one which is not included. Okay, so for this, we are going to find for the area of our triangle. And again, we have to remember our formula, which is base times the height all over 2. So there is a need for us to memorize the different formulas so that if we see the figure, you know what to use. So as I have said a while ago, we have here the considered base and the height because this pertains to the radii of the circle, and we know that radii are always equal, okay, for a certain circle. So we have now 9 cm multiplied by 9 cm, and we are going to divide this by 2. So 9 times 9 is 81, and dividing that by 2, we simply have 40.5. Okay, because the 80 is when divided by 2 is 40, and then the 1 divided by 2 is just the 0.5, or yeah, that's 0.5. So we have again cm raised to the second power. Okay, so this is now the area of the triangle. Okay, again, the whole thing here, the circle, has the area of 254.34 centimeters, but the triangle is not included. So in order for us to get the area of the shaded region, we are now going to use the subtraction operation. Okay, so we will get again the area of the bigger figure, which is 254.34, and we are adding that to the area of the triangle, which is the unshaded portion. So 40.5. And by doing this, we have to just bring down the 4. Then this becomes automatically 13. 13 minus 5 is equal to 8. And then we have to subtract 3 minus 0, that is 3. And then 5 minus 4, there is 1. And then this is 2. Okay, so 213.84. So this is the area now of the shaded region. Okay, so we have this blue area, okay, and including that, and the answer that you have there is 213.84, and the unit is cm raised to the second power, or centimeter square. Again, the area of this part which is not included is 40.5 centimeter square. And if you are going to add the whole circle, you are getting the 254.34 cm square. So that's basically the steps on how we can find for the area of shaded regions. Okay, so let's have some more examples. Okay, here we have a square, and inside the square is a circle. So this simply means that we have to subtract the area of our square to the area of our circle. So we have the area of a square as s times s. So that is side raised to the second power. And based on the given, our side is 12 inches. So we will simply have 12 inches multiplied by 12 inches. Okay, and the answer that we are getting here, we can mentally solve that. 12 times 12 is 144 inches square or square inches. Okay, so that is now the area of the whole square at pretending that all are shaded. So what about if you have the area of the circle? Because we have to deduct that or to subtract that from the whole area, which is 144 square inches. So again, we have to take note of the formula, which is pi r squared. And we know already that our pi is 3.14. Okay, so the missing question here is the radius. So look into this figure now because sometimes you might think that the 12 is the radius, but it is not. You have to remember that this pertains now. If you are going to cut this will be the same length as the 12. Okay, and in connection to your circle, this 12 refers to the diameter. Okay, this is the diameter of your circle. Okay, while it's the side or the measure of the side of the square. So the thing or the variable that we are looking for is the radius. Therefore, we have to divide the 12 by 2, making that equal to 6. So we are going to substitute 6 inches for the radius and not the 12. Therefore, this will be times 6 inches times 6 inches. Okay, so we can multiply there. 6 times 6 is 36. So we just copy the 3.14. And then 6 times 6 is 36. We just write that. And of course, the unit of measure is inches square. Okay, so again, we can multiply 3.14. So we have there 3.14 multiplied by 36. Okay, by multiplication algorithm, you have a 24. Then you have 2, so that becomes 8. And then 6 and 3, that is now equal to 18. Now you have to distribute the 3. 3 and 4, that will be 12. You have to append the 1 or to regroup 1. 3 and 1 plus 1 is 4. And then 3 and 3 is equal to 9. And the answer that we are getting is 4. This will now give you a 10. Okay, and then that will now give us 13 as a sum. And then the answer here is 10 plus 1 is 11. So 113. So there are two decimal places. So our answer should be 113. Okay, again, 113.04 inches square. Okay, or square inches. So the next step, again, we are only looking for the area of those shaded region. Therefore, there is a need for us to subtract now the area of your square, which is 144, and the area of the circle, which is 113.04. Now, do not forget your rules when you are subtracting with decimals. There is a need for us to append your decimal point 00. Okay, and then of course after that you have to regroup, making this one equal to 3, and then this will be 10, but this has to borrow from 10, making that equal to 9, and finally you have a 10 here. So 10 minus 4, the answer that you have there is 6. 9 minus 0, there you have 9, and then 3 minus 3, that will just be 0, and then we have now 4 minus 1 is equal to 3. So therefore, okay, 30.96 is the area of the shaded region. Okay, so 30.96, and then you have to include there the unit of measure, which is inches square. Okay, suppose you are given this problem and then you are only to find for this part. okay, for this part only. That could be another question that you can encounter. So in that case, if this is the only part which is being asked, you have to divide the 30.96 by 4. Okay? But because anyway, these are equal to each other. Okay? If this is the case, that will just be an additional question that might be asked. Okay? Let's have another example. Okay, here, find the area of the shaded region. So as you notice in this figure, we are confronted with two figures. So we have one is a trapezoid, while the other one is your parallelogram. Okay, so there are two. The bigger figure is the area of the trapezoid. Okay, I will just have that A sub T, area of a trapezoid. Now, for this, we have to remember, you have to take note that it's base 1 plus base 2. Then you have to divide that by 2, then multiply by height. Okay, by the height. So it's important in determining the base, or in your trapezoid, to be able to determine the base 1, base 2, and the height, because if you interchange this 3 given, there will already be automatically a mistake in the result. Okay, so what is your clue of your base 1 and base 2? They are always the pairs of parallel sides. Okay, so when you say parallel sides, they do not intersect no matter how far you extend them. So in this case, we have 23 and 31 as our bases or bases. Now, you might ask, where is the base 1 or where is the base 2? So it doesn't matter because we have the commutativity property of addition, which means that if I have 23 plus 31, it's just the same as 31 plus 23. That's the same result that we are getting. Okay, and then the height, always remember that the h pertains to the distance between the two parallel sides. So this is now the distance. It's not the slanting line, but the distance between the parallel sides or the bases. Okay, so we have here 15. So I did not write the unit of measure, but make sure that after finishing the solution, you will be writing them correctly. And then you can try to check if you can cancel the 2 with the height. So it's not. So therefore, what you are going to do is to continue with the operation. So 23 plus 31, we have the answer, which is equal to 54. And that will be over 2 times 15. So 54 divided by 2 is equivalent to 27. So we have it 27, and then multiply that by 15. And the answer that we are getting here is equal to, so we can solve that one, 27 times 15. So there is 35. You have to regroup 3. That will now be 13, and then we just copy the 27. And so our answer is simply, that is 5, 10, 1. So there is 405. So our answer for the trapezoid is 405. Okay, again, the unit is in centimeters, so we have centimeters square. Okay, do not make it raised to the third power even if there are 3, because in here it's just an addition. So 23 cm plus 31 cm is just 54 cm. Okay, there is just a multiplication when we had that multiplying by 15 cm. Okay, and then the next thing that we are going to do is the area of your parallelogram. So looking into your parallelogram again, what will you have? For the area of the parallelogram, it states that you have to get base times the height, and then we are going to that's the answer already. So we have here now your base Okay, as you notice, we have 23 and 31, but definitely you will not be considering the 31 as the base. It should be this part because it ends there. Okay, so this is now the simply the parallelogram. So again, the base is equal to 23 and the height is still equal to 15. So times 15. So when you multiply 23 and 15 there, so we will now get 23 times 15. The answer that we are getting, okay, we have there 15. You have to regroup 1, so that is 10 plus 1, 11. That will now still be or equal to 23. So our answer here will be 5, 4, and then 3. So the answer for the area of our parallelogram here is 345. And since the small triangles here are the one which we are trying to look for, what do? We just simply subtract now the 405. So we have here now the 405 minus the 345. And the answer that we are getting there is equal to 5 and 5 is 0. And then you have to regroup there, making this equal to 3 and then 10. 10 minus 4 is equal to 6. So it's simply 60, and then the unit of measure is cm square. Okay, so again, this pertains now to the area of the two triangles that you can see here. Okay, so that is the 60 cm square. Okay, some more examples. Okay, so find the area of the shaded region. So we have again a square, okay, but there is a circle which is located at the fourth side or 1/4 part of the whole square. Okay, so if this is the case, again, what do? We simply have to find for the area of our bigger figure, which is the square. So the area of the square is side times side. Okay, so that is one question that you have to answer also. What will be the side? As you notice, the 16 there pertains to the diameter of our circle. So 16 and 16, there is a need for us to add an additional 16, and that will now refer to the side of our the side of our square. Okay, so the total for that is 16 times 2 is 32. So there we have 32, and the unit of measure that you have is in meters. So 32 meters multiplied by 32 meters. Okay, so we have to multiply 32 multiplied by 32. So we have a 4, and then 6, and then 6, 9. And the answer that we are getting is 4, 12, 10. So 1024. So that is the area of our square having a side of 32. So it's 1024 meters square or meters square. The next is you have to find for the area of your circle. So the area of the circle, again, go back to the formula. We simply have pi r squared, but then again, your r is still missing. Do not forget that the diameter or half the diameter is the radius. So since we have 16 here as the diameter, we just divide that by 2, making that now equal to 8 cm. So 8 cm is the radius. So we will now have again the pi is 3.14, and we multiply that by r squared. So we have 8 cm multiplied by 8 cm. Okay, we can mentally do the 8 times 8, and that is 64. So what do we do? We simply have to multiply now 3.14 times the 8 times 8, which is 64 cm square. Okay, so again, 3.14 multiplied now by 64. So what do we have? 4 and 4, 16. We have to regroup 1. 4 and 1 is equal to 5. And then 3 and 4, that is now 12. And then multiply by 6, so that is 6 and 4, 24. So you have to regroup 2. 6, 1 is 6 plus 2 is 8. And 3 and 6 is equal to 18. Okay, so the answer that we have here is 6. Then you have 9. And then you have 10. You have to regroup 1. There another 10. And then 1 and 1 is equal to 2. So again, we have 2 decimal places. Therefore, the answer that we are getting here is 200.96. Okay, and then unit of measure is cm square. So since this is now the area which is not included, the 200.96 cm square, the next thing to do is to subtract from the 1024. Okay, so we have now 1024 minus 200.96. So we have to append 0.00. Okay, and then regroup after. So this will automatically be 3. Again, change that to 10, but then you have to borrow from there. So this will become 10, and that becomes 9. So answer here is 4. There is 9 minus 9, so that is 0. And then here, we just have to bring down the 3. So 3 minus 0 is 3. And then we have 2 minus 0 is 2. And then we could just drop that and make that 10 minus 2 is equal to 8. So therefore, the shaded region that you have here is 823.04. Again, the unit of measure that we are getting is cm square. Okay, so that is now the area of the shaded region. Okay, so that is how we solve for the area of shaded region. So it's very important to master the different basic formulas because they will be of help for finding the area of these irregular figures.